At any given moment, there are lots of ships in the world's oceans, and it's really difficult to make sense of so much data. Focusing on the Gulf of Mexico, we use geoanalytics to begin to understand high volumes of data around our platforms in the Gulf. Now, using insights for ArcGIS, we can actually focus on a single platform. Looking at the ship traffic around that platform, we'd first like to filter that information down to our designated restriction zones. So now we're just going to be focusing on the traffic in and around our platform. Now, using a tree map and vessel classification, I can start to get a sense of the types of vessels approaching the platform. We have some supply vessels, we have some tankers, some bulk carriers, but there are a lot of research and survey ships. Now, I also want to take a closer look at the velocity of these vessels. So I'm going to create a column chart. My emphasis is going to be on the average velocity. We start to see that our larger tankers, they're moving quickly, but they're further away from the platform, while our slower supply vessels are slowly approaching the platform. Now I can also create what we call a data clock. And this gives me a sense of when most of the traffic is occurring. But I'm more intrigued by the number of research vessels. So we're going to explore the interactivity between these cards. The research vessels are moving slowly, but it's throughout the day. We see a high incidence between the hours of 4 and 6 a.m. And when I scroll over to my map, I notice a high occurrence of a particular vessel, the Osprey Explorer. So let's take a closer look. So we're going to filter our data based on that vessel by its name. So let's type in here. I don't type as fast as Shannon. So now we just have the Osprey Explorer, but I'm also interested in its path of movement. So we're going to bring in its path. Now, zooming into our platform, we start to see a really distinct pattern of movement. Now, our goal here is to find where similar patterns of movement exist. And to do so, my colleague Mansour is going to use big data analytics to explore the broader Gulf for similar patterns of movement. Mansour?
Thank you, Elvis.
You're welcome.
What Elvis came across is actually an area we call it the seismic navigation area, and it has a very distinct pattern. What we want to see is, can we plow through a lot of data and look for other similar pattern in the Gulf area? So let's start with the data. What you're seeing on the map here is a sample data from our friends at Spire that gave us 3 months worth of data, and that contains about 1.2 billion records. Right? When we're looking at this map, we see a bunch of dots. We do not see the pattern. However, what you saw before, there's a very clear distinction how these seismic navigation go. They go back and forth, and they kind of clump together. So how do we look up for these patterns? We use big data analytics, the big data toolkit, that can now plow through billions of records and can use an algorithm we call micropathing. And by clustering these micropaths by space and time, we can tease out survey area, right? So what we were going to plow through the data, and we're going to come up with these survey areas, and we're going to go from that to this. These are potential survey area. We went from a bunch of points to potential area, and actually this is the area that Elvis has found. Let's zoom into it, right? And we can see it, and what we're going to come up is with these micropaths, and we can clearly see how they're moving up and down in it. Let's go to another detected area, right? And we can see the movements. And of course, if we keep on digging more and more, we can see some beautiful pattern. Isn't that beautiful here, like how we can detect that? So using big data analytics, advanced geoclustering for pattern recognition and path recognition here, we can get some deep insight from the data and can be teased out. So any hidden pattern now are suddenly visible that you could not see before. That's pretty cool. Thank you. Back to you,
All
Dev.
right, Mansour, thank you.